Welcome back to the video guys. In this video, we'll be discussing question 4, 5, 6 and 7 of activity 2.3. So let's get started. Here in the question number 4, the first two option talks about the homogeneous and the non-homogeneous system of linear equation. So if we have a system Ax equal to B, then there are two possibilities when we talk about B. The first possibility is B can be a zero vector. And the second possibility is B is not a zero vector. So if B is a zero vector, then in such scenarios, we call it a homogeneous system. Homogeneous system of linear equation. And it is denoted by Ax equal to 0. Whereas if B is not equal to 0 vector, then in such scenarios, we call it a non-homogeneous system of linear equation. So this was all about the option number 1 and 2. So option number 1 says that if B not equal to 0, then it is homogeneous, so it is wrong. Whereas the option number 2 says if B not equal to 0, then non-homogeneous. That means the option number 2 is correct. Now, moving on to the option 3 that says V is a solution of the system equation Ax equal to B. Then 1 by C times V is a solution of system of linear equation C Ax equal to B with C not equal to 0. So let's discuss option number 3 over here. So in option number 3, it says if we are given a system Ax equal to B and we know V is the solution of this system. So that means we can write AV equal to B. Now, if we have this equation AV equal to B, then we can multiply 1 by C on both the sides given C is not equal to 0. If that is the case, we can pair up 1 by C and V together to make it V by C. And on the right hand side, we'll be having B by C. So this means that V by C satisfies the system Ax equal to B by C. That means V by C is a solution of system Ax equal to B by C. Now, I can write the same thing as C times of Ax equal to B. That means V by C is a solution of system C times of Ax equal to B. So that means option number 3 is correct as well. Moving on to the option 4 that says Ax equal to B is a system of linear equation. If A is invertible, then adjoint of Ax equal to B also has a solution. Okay, so let's discuss option number 4 in this page. So it says that A is invertible. So if A is invertible, then it means determinant of A is not equal to 0. Then only A inverse would exist, right? So we know this really important property of matrices that says A times adjoint of A is equal to adjoint of A times A, which is equal to determinant of A times I. So we can pick any equation from here. So I'm going to pick A times adjoint of A equal to determinant of A times I. Here, if I take determinant on both the sides, it could be written as A times of adjoint of A whole determinant is equal to determinant of A times I. Now, I can split this thing up and write it as determinant of A times determinant of adjoint of A. And on the right hand side, since determinant of A is a scalar quantity, and whenever I take a scalar quantity out of a determinant, I just put its power as order of the matrix. N here is order of I. Now, times determinant of I. We know that determinant of matrix I is equal to 1. So here I have determinant of A times determinant of adjoint of A equal to determinant of A to the power n. Now I also know that determinant of A is not equal to 0. That means I can divide both the sides by determinant of A. Then it will become determinant of adjoint of A equal to determinant of A to the power n minus 1. Again, it is a really nice property that you can have in your mind. And we'll be using the same property to solve this question. So the question says the determinant of A is not equal to 0 and we know that if determinant of A is not equal to 0, the determinant of adjoint of A will also be not equal to 0. Why? Because it's basically equal to determinant of A to the power n minus 1. So if this quantity is not equal to 0, then this quantity will also be not equal to 0. Okay. So given this, we have the system adjoint of A times x equal to b. What can we comment about this system? So we have seen this multiple times. If we have ax equal to b with determinant of a not equal to 0, we can directly say that the system has a unique solution. Has a unique solution. So this is also the case where determinant of adjoint of a is not equal to 0. So we can also directly say here the system has a unique solution. And this was asked in the option number 4, that whether the system has a solution or not. And yes, the system has a solution and it is a unique solution. Okay, so this was all about option number 4, question number 4. Now let's move on to the question number 5. So here question 5, 6 and 7 are based on this data, where C is the cofactor matrix of this given matrix. So if I call it A, so C is the cofactor matrix of this given matrix A. Now it is asking me to find the value of C12. So I know that C12 is basically minus 1 to the power 1 plus 2 times of this determinant, where I will eliminate the first row and the second column. So I'm left with this matrix 1, 1, 2, 1. It is equal to minus 1 to the power 3, which is minus 1, times this determinant, which is 1 minus 2, which is minus 1 again. So minus 1 times minus 1 is equal to 1. So the answer of this question is 1. Now, moving on to the question number 6, that says find the value of C22. Now C22 is equal to minus 1 to the power 2 plus 2 times the determinant of the matrix obtained on deleting the row 2 and column 2. So this is my row 2, this is my column 2, and if I delete both row 2 and column 2, I'm left with this matrix 3, 3, 2, 1. And I'll just take the determinant of the matrix 3, 3, 2, 1. And this will give me minus 1 to the power 4 is plus 1. And it is 3 times 1, that is 3, minus 3 times 2, which is 6, which is equal to minus 3. So here the value of C22 is minus 3. Now, moving on to the last question for this video, which is find the sum of the elements in the third row of C. So the third row of C will have the elements is C31 plus C32 plus C33. So C31 is minus 1 to the power 3 plus 1 times uh, the matrix over here, which is 2301, plus C32 is minus 1 to the power 3 plus 2 times determinant of the matrix 3311, and then I have plus minus 1 to the power 3 plus 3 times the determinant of the matrix 3210. So I can write this as minus 1 to the power 4 is 1. So 2, then minus 1 to the power 5 is minus 1 again. So plus minus 1 into this is 3 minus 3 0. And then we have plus this is minus 1 to the power 6, which is 1. And it is 3 times 0 is 0, minus of 2 times 1, that is 2. So it is minus 2 here. So I have 2 plus minus 2, which is equal to 0. So the answer of question number 7 is 0. So thus we have completed the contents for this video as well, and in the next video we'll cover the remaining questions of the activity 2.3. So till then, bye.